So in this video, we'll talk about manual testing interview questions, which is good for fresher or experienced. So I will review some of the important questions and I'll skip some basic questions, which are direct questions, so that you can refer to direct questions directly on Google search or some textbooks. So I will review some important questions that you need to understand to be successful at manual testing interview, right? Please watch this video till the end to get full details of these questions and answers, and subscribe to my channel QATutorials to get latest videos I post in this channel. So let's get started and see what are the various questions that will be asked in manual testing interview and how you can answer them. So let's get started with the basic questions. So the first question is, what is software testing? This is a very basic question so that we can answer. A process of analyzing software item to detect the differences between existing and required conditions. Basically, how the application is working and what are the requirements, right? So we are trying to identify the differences between existing and required conditions and to evaluate the features of the software item. So what is software testing, right? It's the process of analyzing a software item to detect the differences between existing and required conditions, right? So what is the current state of the application and what is the required state of the application, right? So we are trying to identify these differences and to evaluate the features of the software item. This is the basic basis of software testing, right? To identify defects and also to test features of the software item. And there's a couple of roles in software testing, like test engineer, SDET, right? Software developer, development engineer, and test, like software engineer, development engineer, and testing, and developer, right? There is various differences and what are the different roles. So in summary, the test engineer is only testing the test cases and identifying the fail or pass and how to break the software. That is the main goal of test engineer. Whereas software engineer in test, right, development engineer in test knows the system functional objectives as well as quality objectives. They will do the functional objectives as well as quality objectives like performance, security, like some non-functional requirements and automation. Right? But developer thinks how to develop a system and make functionality work. That is the main goal of developer, right? So these are the main differences. So these various skills, right, for test engineer. Test engineer does not need coding knowledge, right? But if you are a SDET, you need to know coding and testing also, right? Developer requires coding knowledge. And test engineers work with test lifecycle, like designing of test cases and execution. SDET is involved in designing, development, and testing, right? And test engineer doesn't need to know about automation, and if there is a repetitive task, it doesn't need to do anything. But if you are SDET, if there is a repetitive task, you can do some coding and reduce the timing for completing the repetitive test cycles, right? Developers don't deal with such tasks, right? When some testing is very repetitive, the SDET will try to automate that part. Test engineers are not expected to reach up to the code level and tune the performance. So there is no requirement for test engineers to do performance and all that. So, but if you are SDET, you should do performance tuning, security threats, and also suggest improvements and reach to the code, and you can also review the application code for performance and suggest improvements to optimize the code. So developers are only expected to code the functionality which is expected by the customer. So these are the main differences. So the role of SDET is role and responsibilities of SDET are higher, and if you are a beginner fresher, you can target as test engineer in the beginning, which doesn't require coding knowledge, only you need to have a testing knowledge. Once you have comfortable with testing, you can learn some programming skills and performance engineering skills and automation engineering, and then you can start become an SDET as the career progresses, right? But if you are comfortable with coding and understands automation, SDET gives you more higher opportunities. Right? The SDET role is as comparable as a developer role, so it's a very competitive role. Right, so then next question, what are best practices of writing test cases? Right, how to write test cases? We have like different testing techniques, but you should have some practices to better create effective test cases. So these are some of the points we need to understand. Write test cases with end user perspective. Write test steps in a simple way that anyone can follow them easily. Make the test cases reusable, right? So when you create test cases, keep them in mind to able to reuse them, right? Also, when you prepare test data, they should be reusable, right? You should set the priority for each of the test cases. Anyway, you have to provide test case description, test data, expected result, precondition, post condition for all the test cases. Also write invalid test cases along with valid test cases, follow proper naming conventions, and review the test cases regularly and update them if necessary. So it's always we need to update the test cases regularly based on the changes and based on the feedback. That is important. So these are some of the best practices for writing test cases. So there is another question that's asked is, what if the software is so buggy it cannot really be tested at all? So what are we going to do in that case, right? So if it is software is buggy, we're going to report the bugs, categorize them based on the severity, and if there are critical bugs, basically it will affect the schedules and indicates deeper problems in the software development process. So you need to let the manager know about the big bugs with proper documentation as evidence. If it is so buggy, there is maybe inherently there is some problem with the software development process. So you need to raise all the bugs and update the managers about issues and the issues in the system. What are quality assurance and quality control? So quality assurance is basically involves process-oriented activities. That means it ensures prevention of defects in the process used to make software applications. It's like a process, right? Like say, suppose if you are a development, if you are doing development, you need to have requirement documents, or you need to have SRS, right? You need to have design document, you need to have architecture document. So it's like a process-oriented activities. So the defects don't arise when the software application is developed. So when you follow a process, you will not create new defects in the process, right? So that's quality assurance. So quality control involves product-oriented activities. That means executing the program or code to identify the defects in the software application. So this is basically you are trying to test the application, developed application, and trying to identify the defects, right? So quality assurance is basically process-oriented and quality control is product-oriented. So if you are confused about any of these questions, put it in the comment section. I will explain a little more. So then there is another good question is, what is verification in software testing, right? So verification is the process to ensure that whether we are building the right product, right? To verify that requirements which we have, and to verify whether we are developing the product accordingly. So the product is getting developed as per the requirements. So these what are the activities in the verification process is inspections, reviews, and walkthroughs. Right. So inspections, reviews, and walkthroughs is the verification process. What is the validation is basically what the test engineer will do. So we are building validation is whether we are building the right product, right? To validate the product which we have developed is right or not. Activities involved in this is testing the software application itself, right? This is actual testing activities, validation. Verification is basically high-level inspections, reviews, and walkthroughs, right? That is difference between verification and validation. This is a very common question asked in the interviews. What is test strategy? So this is the test strategy is basically high-level document usually developed by project manager. So it documents, captures, approach, how we go about testing the product and achieve goals, right? So it's normally derived from business requirement specifications. Document like test plan are prepared by keeping this document as a base. So test strategy is high-level document. Based on that, your test plan, test cases, and test designing will be done. Right? What is a test bed? Right? You normally hear these word test bed. Test bed is nothing but a test environment, right? It also consists of hardware, software, network configuration, application under test, and all related software. So everything, right? So whatever you need for your test environment, including hardware, software, network configuration, application under test, and other related softwares, is all called as test bed, right? What is a test harness, right? So now you know about test bed. What is a test harness, right? Test harness is basically collection of software and test data configured to test a program unit by running it under various conditions, which involves monitoring the output with expected output. A test bed is basically you will have your test data as well, and also the software. We prepare the software test environment will be there, plus also test data also will be there to verify the to test the program and then verify the outputs against the expected output. So you have everything, like you have your test scripts, your test data, test expected results, everything will be there, and you execute and then get the outputs, right? That is test harness. So test bed is only environment. Test harness is including your test inputs and outputs and expected results and things like that. What is a test closure? Test closure is basically the formal process to complete the testing process. So this contains total number of test cases, total number of test cases executed, total number of defects found, total number of defects fixed. So you have all the stats when you do the test closure, and so total number of defects, bugs not fixed, and total number of bugs rejected, right? All the data will be there to complete the testing process for the cycle. So what are the various activities of test closure? Test completion check, whether we executed all the tests or not, right? Did we skip anything deliberately? Any known defects that should be fixed, default for a future release, or accepted as a permanent restriction. Test artifacts, right? So we're generating different test artifacts. Tests and test environment should be handed over to those responsible for maintenance testing. Known defects accepted or deferred should be documented and communicated to those. And various lessons learned, those should be there as part of it, and archiving any results, reports, logs, other documents. This is all part of the test closure activities, right? Then there is very common question about what is test coverage, right? So there is something called test coverage and code coverage. Let's see the differences between these two. So test coverage helps in measuring amount of testing performed by set of tests. Test coverage can be done both functional and non-functional activities. So it assists testers to create tests that are cover areas which are missing. Like if you have like a requirement traceability matrix, you can easily understand like how much requirements are you covering using this test coverage method, right? What is a code coverage? So code coverage is kind of like a white box testing technique, right? Code coverage is about unit testing practices that must target all areas of the code at least once. So it's basically done by developers or unit testers, right? So that is the difference between test coverage and code coverage, right? Test coverage is kind of a black box technique. Code coverage is kind of a white box technique. So what are the various common components of a defect report? It's a very simple question. So you can put project name, module name, defect ID, defect detected on, defect detected by, priority, severity, defect resolved on, and defect resolved by. These are some of the common components of a defect report. Then there is something called, this will be a very interesting question, like difference between integration testing and system testing, right? So you will hear this word frequently. And let us see what is the difference between integration testing and system testing, right? So integration is kind of a low-level testing, like you're integrating different modules, but system testing is high-level, right? So system testing is performed after integration, but integration is performed after unit testing. So there are different types of integration testing and different types of system testing, right? So you have like top, bottom, bottom, top, right? System testing is like regression, sanity, usability, load testing, performance, maintenance. These are all come under system testing, right? So basically in the integration test, you are doing functional testing and validation in introduction between two modules. So system testing has non-functional testing like usability, performance testing along with functionality. So performed to test whether two different modules interact effectively with each other or not, right? So performed to test whether product is performing as per user expectations and the required specifications, right? So this is how who does the integration. It can be done by testers and developers. System testing done only by testers, right? So the integration normally happens between individual modules, but system testing happens on the complete software application. That's why it's called as system testing. So these are some of the differences between integration testing and system testing, right? To understand like what we are doing when you are in the testing phase, whether we're doing integration testing or system testing, right? And let's see some more questions, right? What is alpha testing? So alpha testing is done by in-house developers who developed the software and testers, right? Sometimes alpha testing is done by client or outsourcing team with the presence of developers and testers. Like something done in the in-house is called alpha testing, right? Just basically whenever we do testing on project, this comes under alpha testing, right? What is beta testing? So beta testing done by limited number of end users before delivery. Usually it is done at the client place, right? So basically you give access to a limited number of users to the application and you are beta testing. Then there is something called gamma testing, right? So don't get confused with the terms. These are used, each one is used for different purpose, right? So gamma testing is done when the software is ready for release with specific requirements, it is done at the client place. It's done directly by skipping all the in-house testing activities. So there won't be any alpha testing. So directly you are releasing the software to the client. Then it's called as gamma testing, right? So some cases, some softwares will do that. Then what is smoke and what is sanity? Smoke is done as we verify the build which is received from the development team, whether it is testable or not. It's also called as day zero check, right? It's done at build level. Just verify high level whether key features are working or not. That is smoke. And there is sanity is done basically on the release phase to check main functionality of the application without going deeper. It's also called a subset of regression testing. So it is done at release level, and there is full video on the differences between sanity and smoke testing available. So you can watch my video on what is the difference between sanity and smoke testing. These are some of the points in the smoke testing and sanity testing when it is done. So smoke is done on initial builds and sanity is done on stable builds, right? So what do you do and all that? You can watch the video as well. And let's look at retesting. So retesting, what is retesting? This is a common question that is asked to ensure that defects which are found and posted in the earlier build or fixed and not in the current build. That is called retesting, right? So you raise some issues in the previous builds. The retesting allows you to test them in the current build. So that is retesting. So basically this is the example. If you build 1.0 is released, so test team found defects 1.0.1 and 1.0.2 and posted, right? So build 1.1 is released. Now testing defects 1.0.1 and 1.0.2 in this build is retesting. So then the next question, right? What do you mean by regression and confirmation testing? So regression is you are testing the application along with the modified code. It doesn't break anything which was working earlier. What is confirmation testing? Usually testers report a bug. When test fails, dev team releases a new version of the software after the defect is fixed. Now the testing team will retest to make sure that reported bug is actually fixed or not. That is confirmation testing. It's kind of a retesting basically. Confirmation testing. Regression is basically we're trying to see that it doesn't break anything which is working earlier. What is the recovery testing? So there is something called recovery testing. So this is basically to see how the system recovers after a crash or hardware failure, right? This comes under non-functional testing. So whenever the system crashes, how easily it recovers, right? So this is a recovery testing. Suppose sometimes when you do Word document, you're doing Word document, if you lose power, Word document will try to recover your document once system is up. So that is kind of a recovery testing. Compatibility, right? So compatibility is basically deploy and check whether application is working as expected in a different combination of environmental components, right? So like if it's working on different browsers, different mobile devices, those things comes under compatibility testing. So there is another important question called exploratory testing, right? So this is basically done by domain experts who have knowledge on the application, who does the random testing to verify any open issues in the software. That is called exploratory testing, right? So that's a number of questions. Then we have a couple of more questions that we talk about. What is called defect clustering, right? So defect clustering is basically a software testing means a small module functionality contains most of the bugs and it has the most operational failures. Most of the times, if you have like multiple modules, sometimes defects may be clustered in one module, one or two modules. So that is called defect clustering. Then there is something called pesticide paradox. What is pesticide paradox? It's basically the process of repeating same test cases again and again. Eventually, the same test cases will no longer find new bugs, because if you are executing same test cases and all, developers will fix the issue. So after some time, you may not be able to find bugs with that same test cases. That's why it's important to review test cases regularly and add and update them to find more defects. So that is called pesticide paradox in software testing. So there is another defect, defect cascading, right? So defect cascading is triggering of other defects in an application. So when a defect is not identified or goes unnoticed while testing, it invokes other defects, right? It leads to multiple defects in the later stages and results in an increase in a number of defects in the application, right? So that is called defect cascading, right? So if you didn't find some defect, it may hide some other defects in the system, right? So when the defect comes out, it may add new defects into the application, right? So suppose, for example, if there is a defect in an accounting system related to negative taxation, then negative taxation defect affects the ledger, which in turn affects the other reports such as balance sheet, profit, loss, and all. So that is a cascading effect, because we didn't find the issue related to negative taxation, so it will impact other modules once it found that defect. That is called defect cascading. And there is a fundamental differences between what is a defect, right? What is a bug? So defect is found by developers in the development phase, right? So bug is found in the testing phase, right? An error. So we cannot compile error or program error due to coding mistakes. So that is called an error. That's an error, like it's a build issue. What is a failure, right? Failure in the sense, once the product is deployed and the customers find any issues, then they call the product as a failure product. After release, if end user finds an issue, then that particular issue is called as a failure. That is a failure. So that's the difference between defect, bug, error, and failure. So defect is found at development level, bug is found at testing level, error is basically not able to compile or use the program, right? Compile the coding mistakes, right? Failure is basically once the software is released, it is not usable. User finds issues in the software, that is called as failure, right? Then we have like bug severity and bug priority. Bug severity is defined as impact of the bug on customer's business. It can be critical, major, and minor. That is bug severity. So priority is defect priority is how soon the defect should be fixed. It gives the order in which the defect should be resolved. Right? It can be high, low, or medium. So developers decide which defect they should take up next based on the priority. Most of the time, the priority is set based on the customer requirement. So here is some examples of bug priority and severity, right? High priority and high severity. Submit button not working on a login page and customers unable to log in. So that is high priority and high severity. Low priority and high severity, crash in some functionality, which is going to deliver after a couple of releases, right? So that's a low priority. High priority but low severity, spelling mistake of a company name on the home page, right? So high priority but it's not severe, right? Low priority and low severity, FAQ pages taking long time to load. So these are some examples of priority and severity. So then we have like a couple of more questions. What is bug leakage? A bug which is actually missed by testing team while testing and build was released to production. If now that bug was found by the end user or customer, then that is called as bug leakage. Leakage means it's not found during the testing process. That is a bug leakage. What is a bug release? Release the software to production with the known bugs. Then we call it as a bug release. These known bugs should be included in the release notes. Right? So suppose we are releasing something with known issues, so then we can call it as a bug release. Probably we are releasing it to fix some other issues in the application. That's the bug release. What is the defect age? Defect age is defined as time interval between date of defects detection and date of defect closure. Right? Defect is basically date of defect closure minus date of defect detection, like how long the bug is open. That is the defect age. This is some of the example of a defect age. So then there is a very important question: which test cases are written first, white box or black box? So what do you think? Right? The simple answer is black box is written first, because black box is written first compared to white box. So prerequisites to start black box are requirement documents or design documents. So these are available before initiating a project, right? Prerequisite to start white box testing is internal architecture of the application, right? So the internal architecture of the application is available in the later part of the project, that's in the designing phase. So that's why black box is written first compared to white box, right? So these are some of the questions of manual testing interview questions which are important, and you should also learn about basic techniques of black box, white box, and also test case design techniques like boundary value analysis, equivalence partition, decision table, and state transition, and all that. So if you master these questions along with the basics of testing, you should be able to crack the interview very easily. So I hope this video is helpful to you guys. So please post in the comment section if you have any questions, and don't subscribe to my channel QATutorials, and click on the bell icon to get notifications whenever